All science fiction movies are lying to you. Interstellar travel, galactic roaming, it's all nonsense. The truth is, humanity can never leave the Milky Way, not in a million years, but never. Why? Because the universe has drawn a cage for every civilization, locked by three mechanisms: the speed of light limit, conservation of energy, and time dilation. These three locks are each a death sentence. Currently, the fastest human probe has traveled for 47 years and only covered 24 billion kilometers. Sounds far, right? But to fly out of the Milky Way, it still needs 1.6 billion years. By then, Earth won't exist. This is the universe's most cruel design. It lets you see infinite stars but never lets you approach. But the question is, why these three locks? Why did the universe design it to be so hopeless? First, the speed of light limit. In 1905, when Einstein proposed the special theory of relativity, the entire physics community exploded. Not because of the complexity of the formula, but because he revealed a cruel fact. The speed of light is the universe's ultimate speed limit, $299,792 kilometers per second. Sounds fast, but for flying out of the solar system, this speed is slower than a snail climbing a wall. What's more terrifying is that this isn't a technical issue, it's a physical law. When you try to accelerate an object with mass, you encounter a bizarre phenomenon. The faster the speed, the greater the object's mass. As it approaches the speed of light, the mass of a single screw would approach infinity. To continue accelerating, you would need the energy of the entire universe. This is like someone telling you, you can run, but your shoes will get heavier and heavier until the Earth cannot support them. This is not a challenge, it is a curse. The second lock is even more absolute: conservation of energy. Suppose we actually built a spacecraft that could approach the speed of light. How much fuel would it need? The answer will leave you in despair. According to the mass energy equivalence $E equals mc²2, the energy required to accelerate 1 kilogram of matter to $90 of the speed of light is equivalent to detonating 2,000 Hiroshima atomic bombs. A crewed spacecraft needs to be at least 100 tons. What does this mean? You would need to convert the mass of the entire planet Jupiter into pure energy to barely start this journey. Jupiter, that gas giant $318 times the mass of Earth. Even more desperately, this is just for acceleration. You also need to carry the same amount of fuel to decelerate. Otherwise, you would crash into the target galaxy at near light speed, instantly turning into a fireball of plasma. So, the actual required energy must be doubled. Someone asks, what about nuclear fusion? No. The sun shines and produces heat through nuclear fusion. It's theoretically feasible, but efficiency is a fatal issue. The most optimistic nuclear fusion reaction has an energy conversion efficiency of only 0.7%. This means you would need to burn $400 Jupiter-sized planets to complete one round trip. The Milky Way only has 8 gas giants in total. Where would you find $400 Jupiters? The third lock is the most insidious: time dilation. This is the most counterintuitive prediction of relativity. Suppose you actually boarded a near-light speed spacecraft flying to Proxima Centauri, for light years away. To you, the journey might only take 2 years. You happily return to Earth, only to find 10 years have passed. Your children have grown up, your parents have aged, the era has changed, and everything you know has changed. You have become a stranger from the past. The further the distance, the more cruel this cleavage becomes. Flying to the center of the Milky Way, $26,000 light years away? To you, it might only be 20 years, but $50,000 years would have passed on Earth. Your civilization, your language, and all your memories would become objects of study for archaeologists. This is not travel. This is a one-way temporal exile. You can never return to the era from which you departed. But the greatest irony is that even if we accept the existence of these three locks, the solar system itself is already a gigantic prison. How large is the solar system? Textbooks tell you the radius of Neptune's orbit is $4.5 billion kilometers, but this is only the range of the 8 planets. The true boundary of the solar system is the Oort cloud, a spherical cloud of 1 trillion frozen comets with a radius of 1 light year. 1 light year is $9.46 trillion kilometers. Voyager 1, traveling at $17 kilometers per second, only covered $24 billion kilometers in 47 years. At this speed, crossing the Oort cloud requires $18,000 years. What is the concept of $18,000 years? Human civilization, from the Stone Age to today, is only $10,000 years. Someone asks, why not build a faster ship? In 1976, NASA launched the Helios 2 solar probe, setting the speed record for human spacecraft, $70.2 kilometers per second. This speed is more than 4 times that of Voyager 1, fast enough to fly from Beijing to New York in just 3 minutes. But even at this speed, crossing the solar system still requires $4,300 years. More cruelly, these speeds rely on gravitational slingshots. After the ship leaves the solar system, there are no more planets to borrow energy from. Your speed is permanently fixed at that number, becoming a vagrant, never stopping, never arriving wanderer in the universe. What if we don't rely on rockets, but other methods? In 2016, Hawking and Yuri Milner proposed the Breakthrough Starshot project, using lasers to propel microprobes to $20% of the speed of light, flying to Proxima Centauri. Sounds cool. Let's do the math. This plan requires building a $100,000 square meter laser array with a power output of $100 megawatts, equivalent to the total power generation of China. All this to propel a probe weighing only 1 gram, less than a credit card. And this is just a one-way ticket. The probe has no fuel to decelerate upon arrival at Proxima Centauri. It will pass through the star system at $20% of the speed of light, disappearing into the darkness before taking a few pictures, let alone sending signals. That would require an extra transmitter, but 1 gram is not enough for a mobile chip. So, this plan essentially burns down a national-level power grid just to launch a metal thread into the universe that can never return. Someone says, what about crewed missions? Humans can hibernate for thousands of years and wake up just as they arrive at their destination. Sounds like science fiction, but medical research provides a cruel answer. The biggest enemy of human cryonics is not temperature, it's ice crystals. When cells freeze, water forms ice crystals, piercing cell membranes and tearing DNA. Even with antifreeze, only some organs can be protected. The brain's 100 billion neurons, every connection storing your memory, personality, and everything you are. Once ice crystals destroy those connections, you wake up, but you are no longer you. Even with perfect cryonics, what about radiation? Interstellar space outside the solar system is full of cosmic rays, high-energy particles approaching the speed of light, attacking everything. On Earth, we have the atmosphere and magnetic field for protection. In deep space, these radiations will slowly destroy your DNA, induce cancer, and damage the nervous system. Flying for thousands of years, your body will slowly decay into a pile of mutated cells in the cryopod. What about standby ships? Building a giant generational ship where several generations are born, live, and die until they reach the new home. This is science fiction's favorite setting, but reality is much crueler than fiction. First, the scale. A ship capable of maintaining an ecosystem requires at least $500 people to ensure genetic diversity. Each person needs 2 kilograms of food, 2 liters of water, and $20 cubic meters of air circulation per day. Traveling $4.10,000 years requires storing $36.5 million tons of supplies, not counting equipment wear, medical devices, and entertainment facilities. The total mass of the ship would reach hundreds of millions of tons, $10,000 times heavier than the largest aircraft carrier in history. The energy required to propel it returns to the same dead end, burning hundreds of Jupiters. More fatally, humanity. What would happen to human nature in a closed space, living for thousands of years across generations? History gives us the answer. Closed societies inevitably move towards authoritarianism, superstition, and collapse. The first generation might remember the mission. The third generation will question, why are we flying toward a star we've never seen? The 10th generation will treat Earth as a myth. The 100th generation will completely forget science, reverting to a primitive tribe. Eventually, this ship will become a drifting tomb, with descendants who have lost purpose, memory, and civilization, wandering forever in the darkness. Wormholes are the shortcut for traversing space in science fiction, reaching any place in the universe in 1 second. Theoretically, general relativity does allow wormholes to exist, but to open a stable wormhole, you need negative energy matter. What is negative energy? Imagine a substance with negative mass. It's not attracted by gravity but repels everything. This substance would reverse gravity, tearing a hole in space. The problem is, does this stuff exist? In 70 years, no experiment has observed a single trace of negative energy matter. It's more like a symbol in a mathematical equation than a real thing. Even if it exists, how much is needed? Calculations show that maintaining a 1 meter wide wormhole requires negative energy equivalent to the mass of an entire galaxy, a galaxy containing $200 billion suns, and it must be negative. So, the wormhole is essentially the universe mocking us. It gives you a door but hides the key in a non-existent dimension. Every escape route is welded shut by physical laws, and every theoretical loophole requires a god-tier civilization to exploit, yet we can't even leave the solar system. But the most despairing thing is not the technology, it's that the universe itself is abandoning us. In 1998, 2 teams of astronomers simultaneously discovered a shocking fact: the universe's expansion is accelerating. This discovery stunned the world because, according to common sense, gravity should slow the expansion. But observational data showed that distant galaxies are moving away from us faster and faster. Dark energy, a mysterious force we completely fail to understand, dominates all this, accounting for $68% of the universe's total energy. It's like an invisible hand pushing all galaxies farther and farther away. What does this mean? Galaxies you can see today might be forever lost from sight in 10 billion years. The universe is actively cutting off our contact with other civilizations. Even if alien civilizations exist, we will never meet, because the expanding universe will forever isolate us on our own islands. This is the ultimate prison, not technology, not distance, but the very structure of the universe. So, the answer to the Fermi paradox might be this: it's not that alien civilizations don't exist, but that all civilizations are permanently confined to their respective galaxies by physical laws. The Milky Way may hold billions of civilizations, but we will never meet. We are like prisoners in different cells. We can hear each other's voices but can never shake hands. But is this truly a tragedy? Looking at it from another angle, the Milky Way itself is a gigantic kingdom with $400 billion stars. Even if you explored 1 per second, it would take $12,000 years. It holds scorching blue giants, ancient red dwarfs, mysterious neutron stars, terrifying black holes, rocky planets, gas giants, diamond planets, and rogue planets. The richness of this kingdom far exceeds all human imagination. Being confined here might not be a curse but a blessing. It allows us to stop chasing illusory desires for conquest and focus instead on managing this unique home well. It teaches us humility and grants us responsibility. If intelligent life is so rare in the universe, then we might be the only eye and brain in this entire Milky Way, the only vessel the universe uses to admire its own splendor. So, when you look up at the stars, don't see the cage that confines you. See the infinite heritage that belongs only to us, waiting for exploration. We can never leave the Milky Way, not because of failure, but because we inherently belong here.